Hello, my name is Jose Hinojosa. This is video 1 for College Physics 1301, where we will be applying Newton's laws of energies. So, for problem number 1, we have a picture frame that is suspended by two strings, and what's given is the angles here and the amount of tension that is on string 1, which is 1.7. And it's asking us to determine the tension on string 2 along with the weight of the picture. So the angles that are given is 65, 32, along with the tension. So we're going to break this up into a x and y axis. And so because this one's 65, it reflects across the plane, and this also becomes 65. Same thing over here, that's also 32. So we know that the total forces are equal to 0 because this is in equilibrium. So what we have to determine are all the forces in the x-axis and all the forces in the y-axis. So we're going to determine total forces in the x is equal to, now because this is rope 1, this is rope 2, it's on the left of the y-axis, it's going to be negative. So we're going to start with T2, it's positive. So it's going to be tension 2 cosine, in our case 32, minus T1 times the cosine 65. So because we know what T1 is, we're going to plug that in. So it's going to become T2 cosine 32 minus 1.7 times the cosine 65 is equal to 0. So we're going to turn this into a positive. So it's going to be 1.7 cosine 65 is equal to T2 times cosine of 32. So we want to get T2 alone, so we're going to divide by this in order to cancel this out. We're going to move it over here to this side. So 1.7 times the cosine of 65 divided by the cosine of 32 is equal to T2. So we're going to plug that into the calculator. That's going to give us 0.84 newtons is equal to T2. So 0.84. Alright, so now we have to determine the weight of the picture. In order to do that, we have to find all the forces that are in the y-axis. So now we found our tension, it's going to make it pretty easy. So total forces in the y, it's going to be T1 sine of 65 plus, because both of them are going up, T2 times the sine 32 minus the weight, because the weight is below our x-axis. So because we want to find the weight, we're going to set W is equal to this equation up here. So we're going to plug in our values. 1.7 times the sine 65 plus 0.84 times the sine 32. So again, we're going to do the math for this. It's going to give us weight is equal to 1.98 newtons. If we round it off, it's 2 newtons. Okay, so problem 2 states that there's a skateboarder on a ramp who starts at point A and ends up at point B. So my last name starts with the letter H, so my height is 2.30. Now what they want to know is the initial speed at point A. So what was the skateboarder's speed here so he can end up here? So we know that kinetic energy is equal to potential energy. So it's going to be 1/2 mass times velocity squared is equal to mass times gravity times height. Now because we're not given mass, we can't determine that value. So what we're left with is 1/2 of v squared is equal to gravity times the height. Now because we want to know the velocity, we have to get it alone. So we're going to start transferring our values over. So we're going to multiply, times 2. So that leaves us with velocity squared is equal to 2 times gravity times the height. So because it's squared, we have to find the square root of this side. It's going to be velocity is equal to the square root 2 times g times y. So velocity is equal to 2 times 9.8 times, in my case, 2.3. So we're going to plug that into the calculator. So velocity is equal to 6.7 meters per second squared.